Hi, everyone, and welcome back to the Observability and Security track. I'm joined here by Szymon Kedzierski, and we're going to talk about his serverless observability with OpenTelemetry.
Hello, everyone. So let me start with sharing my presentation, and hopefully you can see. So today we will talk about the serverless observability, and I will talk about a bit of the OpenTelemetry project. But I will start from introducing myself. So my name is Szymon Kedzierski, as was mentioned. I'm a cloud solution architect. I worked for Grand Parade. That's a part of William Hill. It's a bookmaker company. We are quite doing quite interesting stuff with near real time data pipelines and so on. So if you are interested, give me a shout. You can connect on LinkedIn with me. So I'm mostly focused on public clouds, working mainly with AWS. I'm also founder of the Lab Well Served, and I'm blogging at Cloud Well Served. So I want to say something about my personal interest as well. I am a big movie fan, so I'm not sure if you recognize that, but that's a Monolith from the Space Odyssey 2001 from Kubrick's movie. It's one of my favorite movies, and in the movie there is this monolith that you can see in this scene. In the movie, the monolith was initiated, and it was like the thing that influenced development of the civilization. So it was the most important thing for the civilization that happened. So I'm talking about that because nowadays the monolith in the IT world is rather associated with something legacy, and we see the microservice architecture to get more and more attention, and that it seemed like a pattern that helps people to innovate quicker. So jumping into the architectures, the microservice architectures. This is an example from my work, basically, that I'm doing on a daily basis. The details are not important here, so you can probably see that this is like the AWS work space with some services, some serverless services. We have few lambdas, we have queues. We have DynamoDB, like a database. We have some external services and so on. So the point here is you can see that there's many moving parts. And in this kind of world, when we have many microservices, we have multiple services that we need to interact with each other. There can be also multiple concurrent invocations, and there are different retries policies for those components. So this kind of architecture, this kind of system is really difficult, in my opinion, to troubleshoot and to operate. Why? Well, we face that problem in the beginning as well, because it's sometimes difficult to find out where is the bottleneck. Why, for example, this kind of system behaves not the way that we want, like it's slow, and then you have to have some way to correlate your logs that the system is producing with metrics that are part of that system. So to operate and to troubleshoot this in a good manner, you will need proper observability. And what I mean by observability, you probably know that, but there are a few things that you have to make sure that they are there. So first of all, you need logs. Probably all know what I'm talking about. We have like structured and unstructured line of text, so that system produces. Then we have metrics, yeah, that's pretty obvious as well. There are values that express some data about the system. So, for example, how many times your function was invoked. And then the part that I want to focus on today are the traces. So the traces show the activity from the individual transaction or a request that goes through your system. So for example, when you I don't know, add an item to your basket in your application, then there is a workflow that is triggered for probably some microservice that gets the request, then saves it to the database, maybe sends an email. Another one, another microservice sends an email with the confirmation that you bought something, and so on. And the trace will show the activity through all the components when you do that request for putting something in the shopping cart, for example. Okay, so let's go a bit deeper, and that's a tracing. It can happen also in the monolith application. But if we are talking about tracing in the microservice or in the serverless as well, when we have multiple services, we have to distribute somehow this, and we have to have the correlation between the events that are happening in your system. So a trace is simulates the entire journey of that request that moves through the system. So in the distributed tracing world, you have a trace, and the trace is actually a collection of spans. What are spans? Well, where there are the operations that are represented, that are representing a unit of work in your request. So you can have like one trace, but you can have multiple spans, and the spans can also go through the whole system. And each span will have a name of the operation that you are doing, but the important part will be the start and the finish, some kind of timestamp, so we can measure how the operation, how long it takes to do that operation. And then you will have also in this spans context. So it's kind of globally unique identifier that will represent that unique request. So for example, trace ID and span ID, and then you will be able to trace it through whole the system. The span can also, of course, have different things like different attributes, events, and so on. But going again more deeper, I was saying that it will need a context. So the context is needed to be passed through the services, just to be able that your system will recognize that this action is part of that particular trace. So, and how it's called context propagation, right? So how this happens? Basically, one service will inject the context into the, for example, HTTP header, and will send it to another service when it will get extracted, so that then you are able to do that correlation. So there are different protocols that you can use for the context propagation. So different headers basically that you can use. For example, WC3 trace header, or like Zipkin B3 header, and so on. Okay, so but how this correlates to what I'm doing on the daily basis? So you will think, okay, yeah, in such complicated systems, or so in the microservice architectures, I want that. I want to have the distributed system in my solution, because I need to know how long it takes to for example, a particular component to call another component and so on. So now your question would be, okay, but what to do next? And then you can think about which standards to choose or how to avoid vendor locking. If you have a look on the picture, it's sometimes like that when there is a proposal of new standard that how this happens. So you can have a read. Yeah. So hopefully that it's not how you will see the OpenTelemetry after this presentation. So what is OpenTelemetry then? There were two projects before the OpenTelemetry one. There is still OpenCensus, that is a collection of language-specific libraries. And for instrumentation, I will talk about the instrumentation in a second. And it's also helping you collect metrics and exposing the data. And there is another project still valid, but it's existing one. So it's open tracing. So it standardized the API for tracing. And those two projects merged in 2019, and the OpenTelemetry arose. So what is the OpenTelemetry then? Well, it's a single set of APIs and libraries that helps you to standardize the way how you collect and transfer the telemetry data. So it's just that, or as much as that. So it's a standard way how we can do it, how you can collect the data. So it does not provide you it does not replace the analytic tool or like the backend where you will analyze the data. So let's say you are using Prometheus, or you are using New Relic, or some tool for different observability data. You will still need that, but when you will want to change that, hopefully using OpenTelemetry help you to do that more without any major changes. I will explain that in a minute. So it's you can think about it as a single transmission system, single transmission system for your data, for your OpenTelemetry data. Okay, I mentioned one thing, that it also allows you to do the instrumentation. So what is the instrumentation? So it's basically adding the observability code to your application. So if you remember, I was mentioning that the trace includes spans. So somehow your application needs to create a span. And it could be done in two ways. Either manual, so you will basically write a piece of code that will use in this case, OpenTelemetry API and SDK to create a span, or you can have the automated way of doing it. So if you use auto instrumentation, there will be need for an agent that will inject the code or inject the span into your application automatically. How it's done technically? Well, it depends on the language, on the framework. So if you know Java, then how it will work is basically it injects a jar into a JVM. And if you are familiar with JavaScript, it will do it that different way. It will load the modules before you actually import your framework and so on. So that works different for different languages, but the idea is the same, that you don't have to do the manual code changes. So which one to use? Well, I'm a huge fan of the auto instrumentation because I don't have to do, or we don't have to do the code changes. But I think manual instrumentation is also important. So sometimes when, for example, your framework is not supported yet, or you need some a more granular understanding how your service works, then you can use manual instrumentation and create those spans by yourself. Okay, so we were talking about instrumentation, and let's go back to the OpenTelemetry as a project. I just wanted to mention a few things about the architecture. So it's composed of the API that application developers use to instrument the code, as was mentioning. Then you have the SDK that actually implements that API. And then very important part is the collector. So collector, as the name implies, collects the data, and it has three parts: receivers, processors, and exporters. And I think you figure it out what the things are, the components are doing in the collector. But what I wanted to mention here, that different protocols or data formats are supported. So it's not just OpenTelemetry that it's just can be used with the some OpenTelemetry format, and that's it. No, actually, the collector can use the data formats that you may be already using. Like if you have tracing with Jaeger, so Jaeger is supported. And say this is for the receivers and also for the exporters. So you can have multiple exporters to multiple tools. So again, if you are sending logs to Prometheus and you want to still use that, then there is exporter for Prometheus. Or maybe you want to send logs to Prometheus and, I don't know, traces to New Relic. So there is a exporter for New Relics and so on. So each vendor also produces should, or most of them at least, produce exporters that you can use to integrate the OpenTelemetry with your tool that you want to use or you are already using. Okay, so just a summary on the OpenTelemetry benefits then. As I was once mentioning, it's a vendor agnostic. So the idea behind it is you will do that once. You will just instrument your application once, and then if you want to use a different analytic tool for different observability data, you can easily change that. You don't have to redeploy all of the applications. Hopefully, you can just change the configuration of the collector and export to the different backend. It has cross-platform support. So I was mentioning that there are different languages, different libraries supported, and it's, as also mentioned, supports both automatic and manual instrumentation. The architecture that I showed you provides separation of concerns. So we have API, SDK, and then we have the collector. And I think that the benefit of OpenTelemetry is also that it does not provide you with the analytic tool features. So in my eyes, the observability, the most important part of the observability is the platform that you use to analyze the data that you gather. So OpenTelemetry is only a way of sending it, but you can still use, or you still should use more sophisticated tools, whatever you want to analyze the data and get the most of the observability of your system. And also it has a large community, so it's a CNCF project. It's well adopted already. There are different parts and different stages for different components. It mainly focused on tracing on the beginning, but logs and metrics are also part of it. Okay, so we understand what is the OpenTelemetry. Now let's be a bit more practical, and I want to show you some examples how you can implement that with my serverless application within AWS. And for doing that, I will explain a few bits that AWS provides to help you to implement that OpenTelemetry standard in their services. So first of all, there is a OpenTelemetry distribution or for AWS distro for OpenTelemetry, to be more precise. So it's a upstream first distribution. So what does it mean is if the AWS is introducing some enhancement, it first contributes to the upstream projects, and then the AWS distro is built from that OpenTelemetry components. It supports different languages like Java, .NET, Go, Python, JavaScript, and probably some more already. And why AWS decided to build that? Well, because they wanted to include their tooling and their support for their services. So they, for example, added some specific metadata for the AWS SDK, or they introduced like the format for X-ray trace. So X-ray is a service or basically a tracing tool from AWS. So yeah, that's why they opened. Oh, I mean, they published the distro for OpenTelemetry. Okay. You probably know Lambda. So Lambda in AWS is a function as a service. So you can just drop your code and it will be executed. You don't have to worry about the underlying infrastructure. Very, very popular service. But if you are not deep into AWS, I'm not sure if you are familiar with Lambda layers. So that's why I wanted to first give a bit understanding, what bit introduction what the Lambda layers are, because we will need that in our demo. So before the Lambda layers, when you wanted to deploy an application using Lambda, then what you had to do is basically package your application in like a zip and upload it to AWS. And the package has to or had to have all the dependencies, and it was very difficult to manage, and the packages were quite big. So AWS came up with Lambda layers, and they basically decouple those two things. So you have your business logic as a one package, and you can package your dependencies or any other software that you depends on in the separate layer, and it can be managed even like separately. So why to use that? Well, because your business logic can be separated from your dependencies, and then it's easier to manage the dependencies if you have like multiple functions that use the same dependencies. Then you can have a central place where you will have them. Then it's when you need to update them, it's also easier, and so on. So we will use Lambda layers in our in my example. I want to show how to deploy OpenTelemetry using the layer that AWS actually provides. So that's why I'm speaking about it. And another component of Lambda that you probably, or if you are not deep into AWS again, you won't know, it's there's a feature that's called Lambda extensions. And a Lambda extension is basically a script that runs alongside your code. and can receive updates about your function via pool-based API. So basically, you have your business logic running in Lambda, and then you can have another binary that actually will execute some other logic. And you might ask, wait, why I would need that? This is the perfect use case for that is actually the auto instrumentation and running the collector from OpenTelemetry. But that's just the one use case that we will use. But Lambda extensions can be used for different purposes, like capturing some diagnostic information or fetching some configuration like secrets or something like that. And how it works in detail is basically when you invoke your function, then there is the initialization stage where your function is initialized. But before that, actually your extension is initialized. Then your function invocation happens, your business logic runs. It can run sorry, it can run multiple times. And then when it's finished, then your runtime is shut down. So first the function runtime is shut down, but then also the extension runtime is shut down. And during that shutdown, you can again do some logic that you need. So all the components are used actually to help you run OpenTelemetry in serverless applications in AWS. In this case, I will show you how to do it with Lambda. So you have Lambda layer that actually will provide you with the package, with OpenTelemetry package. And it will use the Lambda extension to run the collector. So you invoke your function, the function handler will do the logic, and it will send it to the OpenTelemetry. It will send, for example, traces to the OpenTelemetry buffer that will be sent to the collector in Lambda extension. And then there is an exporter that sends the data to whatever you want. By default, for traces, it sends it to X-ray. I will show you in the demo how the X-ray works. Okay, so that's the theory. Let's have a look on the demo, and let's actually run some Lambda function. So there will be we have an application that is quite simple application for the demo purposes, but what it does is basically there is a Lambda function that scrapes the Facebook page and saves it to the S3 bucket. And the Lambda function is fronted with the API gateway, so the user can access the function. And that's pretty much it. And we will, for some reason, the application works really slow. So we will try to figure it out what is wrong. So let me log into my AWS account. Yeah, so give me a second. I need to do the logging. But basically what we will try to do is to use OpenTelemetry to to trace the data and figure it out why our application behaves so slow. And yeah, I'm almost there. Okay, I logged in the console. So let me share my screen again. Yeah, you should be able to see my screen and AWS console. And what I want to show is how this works. So first of all, we will go to API Gateway. And you can see that there is one API. And if I go to stages, there is a production stage. And then I can invoke the function. And you can already see that for some reason, the function, the application is really, really slow. So it's still loading. After a few seconds, yeah, I have like communicated that, yeah, my function executed successfully. But I don't understand why it takes so long. So I can go to the Lambda function. And what I would like to see is what is broken, right? So I can see that I have my OpenTelemetry and API gateway. In the monitor section, there are traces, but unfortunately, there are no traces available for me. Right. So what I will do is, first of all, maybe I would like to use the tracing that AWS provides. So let's do that. And I can enable it. I can enable it for the API gateway first. So it's quite easy because what I need to do is just enable X-ray tracing for API gateway, and I can save the changes. And I will enable X-ray tracing for my Lambda function as well. So in the configuration, in the monitoring and operation tab, I will edit that setting and I will activate X-ray tracing. It's not OpenTelemetry at all. It's X-ray only. But let's save that. Yeah, my function got updated. And let's try to execute the function again, and we'll see if we can see any telemetry data just with the X-ray that is out of the box there. So I'm again in my functions tab. I will go to the monitor, and there is a trace. Let me open it in the new window. Yeah, and you can see that there is a trace map that shows me that there is a API gateway and there is a Lambda function. And then in the timeline, I can see how long it took the application to run. So you can see that for the whole function, whole application, it took like almost 12 seconds to run. And then most of the time here is spent in my Lambda function during the invocation. Well, that's what I was expecting. So the initialization took like 700, 800 milliseconds, but 10 seconds for invocation. But it doesn't say exactly where the invocation, what happens during the invocation. So for more granular instrumentation, we will use OpenTelemetry. So what I'm going to do is to go back to my function, and in the code section, I will add a layer. And AWS provides a ready-made layer for different languages. I will use the Python because this function is in Python. So I have prepared the ARN, so like a name of that layer, and this layer will basically add the package that you need for your Python application. So let me click add. Yeah, hopefully it will be updated successfully. It is. And what I need to do is adjust small configuration change. So what happens is basically the package in the Lambda layer is added into your OPT directory in the environment that Lambda executes in. So what I need to do is add a environment variable that will basically point to the OpenTelemetry execution exe file, executable file. And I will need to go to the environment variable, add environment that's called exec wrapper, and set it to hotel instrument. So you can find that in the AWS documentation how they did that, but that's pretty much it. Yeah, the function get updated. So let me execute it once again. Again, we didn't fix anything, so the function still will run for those about 10 seconds. But now, hopefully, I will be able to see a bit more in the traces. So let me go to the newest trace. And you already see that there is, in the map, there is a bit more that I can see. So I can see the same API gateway that I showed you before, but you see there are more elements. So here we have the handler, the function that actually calls some remote HTTP GET, and this is the Facebook web page that we are scrapping. And then it shows you that it also calls the S3 bucket. And if I go to the timeline, I can see how long it took to do the scrapping of the Facebook. It's like half a second, and then saving it to my S3 bucket. But you can see that the function itself still took 10 seconds. But the problem is not with the Facebook scrapping or with the S3 bucket, right? So it must be something with my Lambda function. So let's get back to my function and examine the code. And yeah, you probably already can see. So there's a cheat here because I just introduced like some sleep in the function just to for the purpose of the demo, but it shows you that actually the OpenTelemetry send the trace for the remote call for the Facebook page and saving it to the S3 bucket as well. So let's do it this way now, that I will remove that and redeploy the changes. And after it's successfully updated, well, let's again execute our function. Now hopefully it will be quicker. Yeah, it's much faster, so I fixed the problem. But let's have a look again on the traces. And now you will see that how long actually took the Lambda function to execute with the API call and so on. So here you can see again the trace. Now the Lambda function, instead of those 12 seconds, it was under 2 seconds, and mainly that the almost 2 seconds was taken by the initialization, and almost 2 seconds was the invocation, where like the scrapping Facebook was half a second and S3 was 280 milliseconds writing to S3 bucket. Yeah, so what we did is quite simply we auto-instrumented our function. You notice that I didn't add any code into my Python Lambda function. It was done by the OpenTelemetry package that I included, and it was automatically exported to the X-ray where I can visually see the trace. Yeah, that's pretty much it. We fix our application. So let me get back to my presentation. And yeah, that was the demo, and that is pretty much what I wanted to share with you. So if you want to try this by yourself and play with AWS a bit, you can go to labwellserve.com/hotel, and there is a free lab that I actually used. So you can just launch it, and it will provide you a free AWS account for 1.5 hours, where you can actually do the same steps as I did. There is an instruction how to do it. I also recommend to have a look on the OpenTelemetry webpage and the FAQ from AWS, where they are explaining why, and how the distro for OpenTelemetry works. And on GitHub, there is also a getting started for Lambda, so you can try it yourself as well in your environment. Yeah, thanks. Do we have any questions?
There's no questions. Let me check real quick. No, some people that are going to try out your suggestion with the lab. Lovely demo, by the way. I really like the simplified view of the traces, and with the addition of OpenTelemetry then.
Yeah, thanks. So yeah, it went okay. I always like the analytics tools that shows you. It doesn't have to be X-ray. It can be whatever you use. There are open source tools that the same, or like some vendors are doing the same work, and yeah, I liked it as well.
Do you know if there's any costs involved of adding OpenTelemetry, for example, to your Lambda functions?
Yeah, there will be, I think. I mean, the cost per se, there is no cost like the AWS that will charge you, but there will be an execution cost, of course, because by execution cost, I mean your function will execute a bit longer. So because there is another code that has to be executed. The package will be also a bit bigger because there is the Lambda layer that's added and so on. But the OpenTelemetry as such is for free. It's just the execution cost.
Yeah, and I mean it's in their benefit to make that footprint as small as possible, right?
Exactly. It's not huge. It also varies among the languages. Yeah.
And just like you showed with Python, for other languages, it would be the same, right? Or something similar.
Yes. So I shared with Python, but there are different languages already supported with the same kind of experience, like Java, .NET Core, and so on. And there are many that are like in various stages of the support, not just for tracing, but for logs and metrics as well.
Yeah. I see one question from Arthur Janus. Have you tried to pair it with some graphing / alerting tool?
Yeah, so I played with New Relic and used that with that tool where we can have alerting set up, and where we can configure alerts based on different scenarios and so on. So yeah, we actually in the company use that. For not only for the serverless applications, but basically for everything, and I think the OpenTelemetry plays a huge role there.
Yeah. Let's see. Some other people are asking, What are some OpenTelemetry analysis tools that you think are good?
Well, it depends what if you want to pay for it or not. Again, so there's Jaeger, definitely, that it's very popular, and Prometheus for logs as well. And for the vendor one, as I said, I use New Relic, and I think it's pretty powerful.